So looking at this problem, we have a right triangle. I should have made this little square here. ABC, where C is our right angle. And I asked you to find side B to the nearest tenth. So in order to do that, let's remind ourselves, this is capital A, so this is lowercase a. This is C, so this is lowercase c. This is capital B, so this is lowercase b. This is where the B is. And we know in a right triangle, a squared plus b squared equals c squared. It's the Pythagorean theorem. And we use it whenever we know two sides of a right triangle and we want to figure out the third side. Remember, the C is always, over here stands for the hypotenuse, a side that's opposite the right angle. So if I put in the numbers, this is going to be 7 squared plus b squared equals 12 squared. And this is 49 plus b squared equals 144. And I'll subtract 49 from both sides, which will give me that b squared equals 95. And therefore, b will be the square root of 95. If we're asked to the answer in radical form, my answer would be the square root of 95. But actually, it said find side B to the nearest tenth. That means we want it in decimal form. So I'll go on my calculator and I'll do the square root. I hope everybody knows how to use the square root button on their calculator. And the square root of 95 to the nearest tenth is 9.7, because the number after the 7 is a 4. If the number is less than 5, then we do not increase it. So B is 9.7 to the nearest tenth. Okay, so let's now see if we can figure out part B. Part B said find cosine A to the nearest thousandth using the above answer. So we want to use this answer 9.7. Now, I left on the board from last time this SOHCAHTOA. That's so important for us to know when we're doing trigonometry. SOHCAHTOA is that way of reminding ourselves that the sine is opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So I asked you to find the cosine of A. So we want to find the adjacent over the hypotenuse. Let's label our sides in terms of those words. Here's angle A. So across from A, this would be my opposite side. The hypotenuse is the one that's across from the right angle. This is my hypotenuse, we know that. And this side, the other side that is right next to angle A, this is what we call the adjacent side. Remember, when we talk about opposite and adjacent, we have to be very clear in our minds as to where our angle is located. It has to be opposite to the angle and it has to be adjacent to the angle. So when I want to figure out what the cosine of A is, I have to do adjacent over hypotenuse. In decimal form, it would be the square root of 95 over 12. Or if we wanted it in decimal form, but I said find it to the nearest thousandth using the answer from before. So we want to do 9.7 divided by 12. And again, I'm going to take out my calculator and use my calculator to do that. So the answer I get is 9.7 divided by 12 is 0.808. I stop there. The next number is a 3, and nearest thousands is 3 decimal places. So in radical form, it would be the square root of 95 over 12. In decimal form, using the answer from before, would be 0.808. And that's how we would do this problem. We actually could now figure out how big angle A is. Again, this is not really required for the final. You'd have to do what we just done. This type of work is required for the final, but actually finding the angle is not. But we can figure out what the angle is by simply doing second cosine 0.808, just sticking it into my calculator again. This is what you would have to. You would then press your second button, and then your cosine button. You should try this on your calculator, and then put in the 0.808. And after you press equal, you should get something like 36.00. We want it to the nearest degree. If we wanted to the nearest degree, would be 36 degrees. Again, the answer to our question was the 0.808. But if we had wanted to find out actually how big angle A is, all we'd have to do is take that number, do second cosine, because this is the cosine, so we do second cosine, put in that number, and it gives us the angle. Again, that's something that you'll do when you take your next course, which was probably going to be, if you're going on in math, you'll be going on to pre-calculus, and there's a lot of trigonometry in calculus, in pre-calculus. So we just touched the tip of the iceberg, so to speak. I'm going to give you another problem to try while I'm taking attendance, and then we'll go a little further on this. Okay, I'm not going to draw a picture now. I'm going to just give you some information. Suppose I tell you that the tangent of theta is equal to 2/11. I want you to find sine of theta in simplest radical form. I'm going to give you a few minutes to try that while I take attendance. Maury. Maury Labrie, there, here. Chelsea. Ariana.
Here.
Hi. Adina.
I'm here.
Hi. Lachey.
I'm here.
Hi.
Hey.
Kava, I know you're here because you were right number one. Terrence. Karide. Hi. Kizia, I know you were here. Faith. Ethan. Isabella. Hi, Isabella. Serenity.
Here.
Hi.
Hi.
Reggie.
You.
Hi.
Uh,
Zamia. Brandon. Michaela. Seraphine.
I'm here.
Hi. Marissa. Renee. Hi. Sky. Jaden. Kennedy. Hi. Felicia. Hi. Okay, Sky, I see you're here. Is Felicia here? Natalia. Hi. Michael. Michael Todd. Cassidy. Chelsea, you're here. Okay, I got you. And Kizzy, I knew you were here. I saw you when you came in. Megan. Kalia. Lauren.
Here.
Hi.
Hi.
And Kayla Zachary. Okay, I think I've got everybody now. And I see some people have answers, so let's see if we can do this problem. Okay, so the first thing I'm going to do is I'm going to draw my right triangle. And since they didn't tell me where to put theta, I always like to put it over here. It's convenient to have it over here. If it's not, I can put it over here, but remember my angle is over here, then this becomes my opposite and this becomes my adjacent. When the angle is over here, remember tangent is TOA is opposite over adjacent. And in this triangle, if this is my theta, this is my opposite side. This is my hypotenuse. My hypotenuse is always across from the right angle. And this is my adjacent. So I'm going to pick 2 to be my opposite side and 11 to be my adjacent side, because my tangent was 2 over 11. So I can pick the 2 to be the opposite side and the 11 to be the adjacent side. Now, in order to find what the sine is so opposite over hypotenuse. So in order to figure out what the opposite, I know what the opposite is. I know it's going to be 2, but I don't know what the hypotenuse is until I do the Pythagorean theorem. So I'm going to do my a squared, which is 2 squared, plus my b squared, the 11 squared, equals the c squared. Since it's the opposite of the hypotenuse, we don't know, that's the c squared. So figuring this out, 2 squared is 4, and 11 squared is 121. So that I get c squared is 125, which means that my c is the square root of 125. Now I look at the instructions. It didn't tell me that they want it in radical form. I'm in decimal form. It said to find it in simplest radical form. So that means I have to leave this with a square root. Well, of course, I can simplify this. Square root of 125 is a square root of 25 times the square times 5, because 5 times 25 is 125. So this side is 5 radical 5. So if I want to find out what the sign is, I'm going back over here. It's opposite, which is 2, over hypotenuse, which is 5 radical 5. The only problem with this is that I don't like a radical in the denominator. If a radical comes out in the denominator, we have to rationalize it. So I'm going to multiply top and bottom by radical 5. So this will give me 2 radical 5. Now, let me just erase this so it has some room here. The radical 5 times the radical 5 will become a 5, and now I have this 5 times this 5, which is 25. So in simplest radical form, the answer is 2 radical 5 over 25. Do you see how many different things from different parts of the term that we put together? We talked about simplifying radicals. We've talked about the Pythagorean theorem. We've talked about sines, cosines, and tangents. All that came together in this particular problem. Again, since it says simplest radical form, we wanted to leave it like that. If the answer was put it in decimal form, or it was just said, if it said, what's the answer, then you could have just done on your calculator in decimal form, it would have been 2 over radical 125. You wouldn't even have to simplify. You could just go to your calculator and do 2 divided by the square root of 125. And then your answer would have come out to be point, if you wanted it to 3 to the nearest thousand, 179, it would be 9 because it's 0.1788. So that would be your answer in decimal form, but they didn't ask it for decimal form. They said simplest radical form. So you had, that's the answer they would have wanted. Is that clear? Okay, great. All right, so I want to go one step. Wait, first of all, let me stop right here. There is homework posted on Delta Math that's due for next Tuesday. Our next class is next Tuesday. This Thursday, of course, is Thanksgiving. I'm also going to be posting a test on Delta Math that will be due a week from Thursday. In other words, on December 2nd. And it will include the topics that we haven't been tested on yet, which is quadratic equations, circles and parabolas. Again, I'm not going to include anything from the other 2 topics, the ellipses and hyperbolas, because that's not covered in Delta Math. So there will be questions on figuring out the center of a circle, etc. And then there's going to be questions on some trigonometry. So that's going to be for a week from Thursday, December 2nd. Our last class is December 9th. In other words, we only have 4 classes after today, 2 next week and 2 the following week. The final is the week of December 12th. I think that the date is probably going to be, just looking at my calendar. Let's see. My guess is that the final will be on December 14th, which is a Tuesday. I think it's 3 weeks from today. So we're really close to that final. I'm not giving you an exact date because I haven't been informed of it. When I have the official information, I will let you know, but it definitely is going to be the week of the 13th of December 13th. Sometime during that week is going to be your final. Again, our last class is December 9th. We're going to be finishing this topic today on trigonometry, and then we're going to be, we have one chapter left to do beyond that. There is going to be a practice final that I will post next week. I'll post it after the Thanksgiving holiday. And again, just like the practice midterm was something that you did for a mark, this practice final is also going to be for a grade. It's going to be considered a test. It's not an option for you to do, you must do it. Again, if you don't do well on that practice test, but you do better on the practice if you do better on the actual final than the practice final, then I'll take that mark as the grade, but you must do that. Again, so there's going to be, aside from any homeworks, there are 2 things that are for marks, for actual grades, the test that's coming up on Delta Math, and then the final practice final, which will be due by the 9th of December. I'll post it earlier, but it'll be due by the 9th of December. That test, that practice final, will be on Blackboard. It will consist of 40 questions, but the final actually is only 30 questions, but it's a good indication of what you're going to see on your final. So that's what's coming up. I'll send this out as an email so you'll understand it better. But in the meantime, for next Thursday, there is, aside from homework, there is going to be this Delta Math test. Okay. We talked about the sine, cosine, and tangent. We call those the trigonometric functions or the trigonometric values that we talked about. Those are the primary trigonometric functions, the more important ones. There actually happen to be 3 others. There's something called the cosecant, which is abbreviated CSC. You also always, just like sine and cosine, you always have to put a letter next to it telling you what angle you're looking at. Notice we can't call it the cosine, we can't call it COS because that is the cosine. So it's abbreviated CSC. There's something called the secant, which is written SEC. And then there's the third one, which is the cotangent, which is abbreviated COT. Now, you don't see these on your calculator. These are not as important as the ones that we talked earlier, the sine, the cosine, and the tangent. Those are primary. These are secondary, but they also, you have to know what they are. It turns out each one of these is also a fraction, just like that, which is a reciprocal of one of the other fractions. This is the reciprocal of the sine. The secant is a reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. In other words, if the sine is the opposite over the hypotenuse, the cosecant is the hypotenuse over the opposite. Let's look at let's take a triangle. Take a simple triangle. Let's call this my angle theta. Let's say this is 3, this is 4, and this is 5. Remember, 3, 4, 5 is a special Pythagorean triple. If you do 3 squared plus 4 squared, you do get 5 squared. So this is a right triangle. These are the proper sides. If you have 3 and 4, this side will be 5. Now, according to this of course is our opposite. This is our adjacent. And this is our hypotenuse. Now, I know that the sine of theta so is opposite, which is 3, over hypotenuse, which is 5. That means that the cosecant of theta is just a reciprocal of this. It's flipped upside down. It's 5 over 3. It's hypotenuse over opposite. Similarly, the cosine of theta, we know, is adjacent. It's adjacent over hypotenuse, which is, for our triangle, 4 over 5. So the secant of theta is a reciprocal of that. It's hypotenuse over adjacent, or 5 over 4. And we know that the tangent of theta for our triangle would have to be opposite over adjacent. That's TOA, 3 over 4. So the cotangent of theta turns out to be the reciprocal of that, which is 4 over 3. In other words, if you know what the sine, the cosine, and tangent is, all you have to do to find the other 3 is to flip them over. Of course, these have to be written as fractions. If it's written as a decimal, let's say it's written as 0.5, then the reciprocal would be 1 over 0.5. You can always get the reciprocal of a number if you put 1 divided by that number. That's how you get a reciprocal on your calculator. So if your number is not written, if it's written as a decimal, just do 1 over that number on your calculator. You'll get the answer. How are you going to remember what goes with what? That's the hard part. Because they're just different. So we know SOHCAHTOA. I think that's been ingrained in us already. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So we have to realize or remember what goes with what. So I'm going to start at the bottom with the cotangent. Why? Because that's easy. It makes sense that the cotangent should pair up with the tangent so that the cotangent is the reciprocal of the tangent. That I don't think anybody has trouble with. The problem is remembering the sine goes with the cosecant, the cosine with the secant. So here's how I remember it. There are only 2 others. There's cosecant and there's secant. So one of them starts with a C and one of them starts with an S. It turns out that the pairs always have one S and one C. So sine starts with S, its pair has to start with C. So it has to be cosecant. Cosine starts with C, so its pair has to start with S, so it has to be the secant. Or you could always see that in each pair, one of the, there's this co prefix. In each pair, one starts with a co and one doesn't. Sine doesn't start with co, so its pair cosecant starts with co. Cosine starts with co, so its pair doesn't start with co, it's only plain secant. And tangent doesn't start with co, so its pair cotangent starts with co. So in each pair, one starts with co and one doesn't. That's another way of remembering it. So once you have the sine, cosine, and tangent down pat, then it's using these mnemonic devices. You can remember cosecant has to go with sine, secant has to go with cosine, cotangent has to go with tangent. Okay, let me give you a problem and see if you could do this. Suppose I tell you that the tangent of theta is 1/3. And I want you to find the secant of theta. And I want it both as a fraction in radical form and decimal. See if you can do this example. Okay, let's try and do this together. So again, I want to make a picture of a right triangle. And then I'm going to put my theta over here. And I was told that the tangent of theta is 1/3. Now remember, tangent is TOA, opposite over adjacent. And this is my opposite side. This is my adjacent side. This is my hypotenuse. So my opposite side I'm going to call 1, and my adjacent side I'm going to call 3. And in order to find the secant of theta, I have to do, well, the secant is one of the secondary ones. And since secant doesn't start with the co, its partner starts with co, so it partners with cosine. So I'm first going to figure out what the cosine of theta is. And then I'll flip it over, I'll take its reciprocal, and that'll give me what the secant is. So the cosine I know is cot, adjacent, which is 3, over hypotenuse. Again, I don't know what the hypotenuse is, so I do my a squared plus b squared equals c squared. So this will be 1 plus 9, which is 10. 10 is c squared. So this has to be the square root of 10 is what my c is. So my cosine has to be 3 over the square root of 10. But again, I didn't want what the cosine was. I want what the secant is. So the secant is just this thing flipped upside down. So it's a square root of 10 over 3. Now, that's the answer in radical form. I can't even simplify that because, first of all, the radical's on top, so that's good. And the square root of 10 can't be simplified any further. So my answer in radical form is the square root of 10 over 3. If I want the answer in decimal form, well, that's when I go to my calculator and I do the square root of 10 and I divide that by 3 and I got 1.054 to the nearest 3 decimal places, the nearest 1,000. So that's how you would do that example. Is there any questions about this? Okay, I think there's much more to trigonometry than what we've touched here. But this is what you have to know for this course. You have to know how to find the third side of a right triangle if you know 2 of them, in other words, the Pythagorean theorem. You have to be able to figure out the sine, the cosine, and tangent, the cosecant, secant, and cotangent of the angle if you're given the triangle or if you're given one of the other trigonometric functions. Those are the 2 things that you must know about trigonometry. Again, we did talk about how to find the angle if we know the trigonometric functions, but that's not part of this course. You don't have to do it for this course. But if you wanted to, let's say you could, since you know that the tangent is 1 over 3, you could just go on your calculator and do secant tangent. You always have to press the second button and then the what angle that you, the function that you know, we in this case know tangent, you'd go second tangent 1 divided by 3 and it'll give you your answer for the angle in degrees. Okay, again, not something you have to know for this course, but certainly what you will have to know for your next course. Okay, so let's just talk a little bit now. We have about 3/4 of an hour left. So I'd like to talk about the beginning topic of the last chapter that we're covering in our book. It happens to be chapter 8, and it's called Exponential and Logarithmic Functions or equations. And the word exponential, I'm sure you strikes a bell with you. You see the word exponent, but the word logarithm is something that's new. Today, we're just going to touch a bit on exponential functions, and then next week, we'll talk about this other creature called the logarithmic function. Now, before we go on to exponential equations or anything of that nature, we better remind ourselves of the rules of working with exponents. I'm just going to very briefly, I know we've done these before. So let's just talk about, let's say I have x squared times x to the 5th. If I have, remember the x, the number in this case, or whatever number has the exponent is called the base. These are called the powers or the exponents. Rule number 1 is when you're multiplying two numbers that have the same base, you add the exponents. So this would be x to the 7th. When you divide, let's say you have x to the 5th divided by x squared. If you're dividing two numbers with the same base, then you subtract their exponents, and this gives you x to the 3rd. If you have a number that has an exponent, and then you raise it to a second exponent. In other words, if you have something like x5 squared, two exponents on something, you can combine those two exponents and you multiply them and you get x to the 10th. So one exponent on top of another exponent, then you multiply those two exponents. If you have something like x squared y 4th, let's say, and that's raised to the 3rd power, let's say, then you distribute that exponent to each of the letters. Now, these you can't combine because these are different bases, but you can do 3 times 2 and get x to the 6th, and 3 times 4 and get y to the 12th. Other important information about this is all, we mentioned it at some point during the term. We also mentioned, let's say if I have something to the 0 power, any number to the 0 power always turns out to be 1, whether it's a million to the 0 power or it's 0.7 to the 0 power, it's equal to 1. If you have something like, suppose you have a to the -2, you have a negative exponent. Remember, that means 1 over a squared. When you have a negative exponent, it tells you to take the reciprocal of your base and make the exponent positive. If the negative exponent is in the denominator, then it comes up to the top. Taking a reciprocal means flipping it around. So anything, this is really like as if it's over 1. If it's in the numerator, it goes to the denominator. If it's in the denominator, it ends up in the numerator. So a to the -2 is the same as 1 over a squared. Now, one thing that we haven't mentioned, let me just erase this because this is just, as I said, a quick review. We didn't talk about what does it mean when we have exponents that are fractions. What does it mean, for example, if I have x to the 1/2 power? And this is something we have to know how to deal with as well. It turns out that the square root x to the 1/2 is equivalent to the square root of x. This could be helpful on your calculator if you want to do something. It's usually every calculator has an exponent button right on the front screen, but not all the radicals are on the front screen. So sometimes it makes more sense to do something like if you wanted to do 144 to the 1/2 power. Like, there are two ways you could do it. Of course, you could just press your square root. This means the same thing as the square root of 144. And you probably know that that equals to 12. You could do it on your calculator by pressing your square root button, whichever way you find it. Sometimes mine happens to be a second. It's anything that's written on top of your buttons usually means you have to first press the second button. When you press the second, the square root, and you put in 144, and you will get 12. Or you could use what's called the exponent button. Most calculators have a button that with this little arrowhead pointing up. That is called the exponent button. If you do 144, and then you press your exponent button, and then you have to put in parentheses because you want it to be a fraction. 1 divided by 2 in parentheses, so that you're telling your calculator that your exponent is the 1/2. If you press it then, of course, you will get 12. So that you can use alternatively the square radical button or the fractional exponent button. We can go even a step further. If I write something like x to the 1/3, that is equivalent to the cube root of x. Notice the denominator of the fraction of the exponent is what we call the index of the radical. I didn't put in a 2 here, but the index of the square root is 2. So x to the 1/3 is the same as the cube root of x. X to the 1/4 would be the same as the 4th root of x. So we can use, and actually in this chapter, we don't use the radical sign at all. Anytime we're talking about a square root or anything, we're always going to write it in this exponential and logarithmic chapter in fractional form. Now, just to make sure you understand what this is about, I'm going to give you a couple of problems that we're going to try on with a calculator, without a calculator. First of all, what if I ask you to do 8 to the negative 1/3 exponent? What are we being told? Well, the 1/3 exponent is telling us that we're doing the cube root of 8, because the 1/3 means your index is 3. And the negative means you're taking the reciprocal. So it's 1 over the cube root of 8, which would give you 1/2. And you could do this on your calculator. If you did in your calculator and you did 8, and then you pressed your exponent button, and then parentheses, -1 divided by 3. And if you do that on your calculator, it will probably come out to be 0.5, because it'll give you an answer in decimal form. And you should be able to do it without a calculator and with a calculator. Here's something for you to try from a previous final. What if you have something like this? Again, here's an example of something that has a exponent. We have a couple of exponents, and one of those exponents is a fraction. Just let's remember our rule. When we have two exponents on a example, then what we have to do is multiply the two exponents. So we have to multiply the 4 times the 1 over 12. Now, let's just put this as 4 over 1, so it's easy to see that it's 4 over 12, which is 1/3. In other words, this is the same as saying 8 to the 1 over 3 exponent. Because when we have two exponents on the same number, we just multiply the two exponents together. And multiplying 4 times 1/12 gave us 1/3. And now we remember 8 to the 1/3 is the same as the cube root of 8. And the cube root of 8 is 2, because 2 times 2 times 2 gives us 8. So that's how we work with fractional exponents. So just one or two more things that I'd like to say. I just want to talk a little bit about what do we mean by an exponential fraction. I'm sorry, an exponential equation or an exponential function. I'm going to write two functions on the board. One is going to be f of x is equal to 3x squared plus 7x minus 2. That's function number 1. And function number 2 is g of x is equal to 3 minus 2 to the negative x. This is a regular, what we call a polynomial function. This is 3x squared plus 2x minus 3. Actually, it's quadratic. And if I ask you what is, for example, f of negative 1, that tells you to put in negative 1 in place of your x. Notice what we don't know, our variable happens to be the base. We know in each case, we know what the exponent is, we don't know what the base is. If I want to do f of negative 1, I'm replacing the x, the base, by negative 1. So this would be 3 times negative 1 squared plus 7 times negative 1 minus 2. And negative 1 squared, of course, is 1. Remember, we do the exponent first. So this is 3 times 1, which is 3, minus 7 minus 2. So the final answer on this was negative 8. This is a regular polynomial function. We've done these things. We've been done f of -1, etc. Look at function g. I'm calling it g because so I can distinguish between the two. The difference between here is that in this case, well, this is just a plain number, but this is a base of 2 and the exponent is -x. The variable is in the exponent. That's what's called an exponential function. Of course, if I want to do g of -1, I do it the same thing by replacing the x by -1. So this is -1. Notice the difference in the expression. We know what the base is. What we don't know is the exponent. We have to be told what the exponent is. Of course, negative and negative become positive. So this becomes 3 minus 2 to the 1 power. And 2 to the 1 power is just 2. So this becomes 3 minus 2. So my final answer comes out to be 1. But again, you have to replace the x. In this case, is going into the exponent. When we have exponential equations, or exponential functions, the base will always be a positive number. I might have something like y equals 2 to the x, or I might have f of x equals -4 to the 2x. The base here is 2. The base here is 4. The base is not -4 because otherwise it would have to be in a parentheses. It just means after you've done, so in this case, if I asked you to find f of -1, you would do -4 to the -2 because 2 times -1 is -2, which would be -1 over 4 squared. Remember, when you have a negative exponent, it means take the reciprocal. Notice this negative just stays in front. It's not part of the base. It's just you're multiplying your whole answer by -1. This is the same as -1 over 16. So when you're dealing with exponential functions or exponential equations, you're going to know what the base is. Your variable is going to be in your exponent, but your base will have to be a positive number. We can't use bases that are negative. Just to finish this off, I just want to show you how you might solve an exponential equation. I'm going to show you how to solve exponential equations that are simple now, and then, but there are going to be some that we're not going to be able to solve until we do much more in this chapter. But here's an example of an exponential equation. Suppose I have 3 to the x equals 27. Again, it's called an exponential equation because the variable, what we're looking for, is in the exponent. What we can try to do to solve this is to write both sides of the equation in terms of the same base. What do I mean? Over here, I'm writing this in base 3. This is, my base is 3, exponent is x. Try and write the other side of the equation also as 3 to some exponent. Now, it turns out I can do this because 27, I can get 3 times 3 is 9, times 3 is 27, is 3 to the 3rd. It's not always possible, but if you can get the two numbers to the same base, then you can ignore the base and just say your answer is x equals 3. Okay, Terrence, I see that you're here. I'll mark you here. Let's see if you could do this example. Suppose I gave you 4 to the 2x is equal to 1 over 16. Let's see if we could solve that exponential equation. Well, I know the base being used here is 4. So let's see what I can do with this side. Can we put it in base 4? So I'm leaving this 4 to the 2x. And I know 16 can be written as 4 squared. So I can write the 16 in base 4, except I want these both to be on level ground. I don't want something in a denominator, but I know 1 over 4 squared is the same as 4 to the negative 2. So I can write this as 4 to the 2x equals 4 to the negative 2. And of course, then, since they both have the same base, I can now write 2x equals negative 2. And that'll give me x equals negative 1, dividing both sides by 2. Again, this all depends on being able to have both sides in the same base. If this would have been 30 instead of 27, I wouldn't have been able to do it because 30 is not can't be written in base 3. Okay, let's give you just one more to try. Suppose I gave you this equation. 2 to the x plus 3 equals 16. See if you could solve that equation. I'll give you a few minutes to try that. Okay, I think we can try this together. Obviously, the base being used here is 2. Don't worry about, they're not going to give you very difficult numbers to use as bases. It's going to be easy numbers like 2, 3, 4, 5, numbers that you're familiar with. Let's go to this side and see if we can write this side in base 2. Okay, so how do we do that? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I have to multiply 2 4 times to get to 16. So another way of writing 16 is 2 to the 4th. Mind you, if this would have been a 17, I would have been stuck. This method wouldn't work. But now I have that on this side, a 2 to the x is 3. And on this side, I have 2 to the 4. Since they both are in base 2, I can just look at their exponents and I can do the x plus 3 has to equal 4 and solve that equation. And that'll give me that x equals 1. Which makes sense, because if this is 1, this is 1 plus 3 is 4, and 2 to the 4th is 16. So that's how we could solve that problem. Okay, Reggie, thank you. I'm glad you came up with the answer also. Yes, 1 is the correct answer. Okay, I'm going to leave it right here. Again, let's remember. There is going to, and that by tomorrow, I would say I will have it posted on Delta Math test number 3, which will cover the material that after the last test, which includes quadratic equations and the circles and the trigonometry. I'm not going to cover this yet. This is too new. Maybe just one question on just working with exponents, but not anything more, no exponential equations. That will be due for a week from Thursday. That's December 2nd. Our next class is on November 30th, a week from today, because Thursday is Thanksgiving. Also, we have, including next week, 2 full weeks of class, 4 more sessions. Our final exam is going to be the week of the December 13th. I'll let you know exactly the time when I do know it, but I suspect it's going to be on December 14th. So make yourself available. I will give, if you can't do it at that time, all you have to do is let me know, but you have to let me know. But again, we'll leave that for until we know exact dates and times. There will be next week, I will post a pre-test on CUNY Blackboard on our Blackboard account. It will be 40 multiple choice questions as a preparation for your final exam. I'm going to use that as a test so that it'll be, you will have some practice in doing the final exam. The final exam will be again on Blackboard, just like our midterm was. The final exam consists of 30 multiple choice questions. The practice final will have 40 questions on it, just to give you a wider variety of questions. But on the final, there'll be 30 multiple choice questions. But you are required to finish, make sure you have your homeworks done. The homeworks must be completed. All the tests must be completed. And of course, the final and midterms must be completed. If you're missing any material and you know about it, it should be easy for you to check. If you didn't take the midterm, etc., then it's up to you to make up that material. If you have any problems, you can always email me and we can work out some sort of time where you could take these tests. If you have anything that's on Delta Math can be taken till the end of the term, it will be available. You might get some slight penalty for doing it late, but it is available. It is your responsibility to go on to Delta Math and make sure that everything that's been assigned is done. If homework is started and it was attempted and you didn't get a perfect mark on it, it doesn't matter. That gives you get credit for homework. the test marks are the test marks. Okay, have a happy Thanksgiving, and I will see you next Tuesday.
Well, Professor.
Bye-bye.